Hi everyone, this video is an exercise 11 of question 2D. So we want to integrate ln x squared. Now here, we need to use a very interesting trick because obviously we can solve this by integration by parts because the first choice might be use substitution. So we can say let u be equal to ln x, so then this becomes u squared. So that's what we want to integrate essentially. And then so here du dx is 1 over x, and now we can just rearrange this. So this gives us dx is equal to x du, and now if we substitute into the interval, then we'll have x du. And so at the beginning we said u is equal to ln x. So if we just basically uh, raise both sides to the exponential function, which will become e to the power of u is equal to x. So here we can have u squared times e to the u du, which is just another integration by parts actually. So we started with u substitution, and then this leads to integration by parts. And then we can just use integration by parts to solve this, and at the end we just need to substitute everything back and have it in terms of x. So that's one approach. But since this exercise is about use of integration by parts, so I'm going to solve this with integration by parts from the beginning. And because it has a very nice trick that is very useful, and that is when we have just ln x and we don't have other functions, so we can write this as 1 times ln x squared dx. And now this allows us to take u equal to ln x squared and then dv dx equal to 1. So that's the trick that I was mentioning, that whenever you just have ln x or ln x squared, that's the trick you use. So you just rewrite that as 1 times that, and then you take 1 equal to dv dx. So u is equal to ln x squared, and dv dx is 1. We also want to find b. So du dx, that's the first thing that we want to do. And this is just chain rule, right? So when we differentiate this, we'll get 2 ln x, and then the derivative of inside is just 1 over x. So we get 2 ln x over x, and then here 1 simply integrates to x. Okay, so we use the formula of integration by parts, uv minus the integral of du dx times v dx. And now, so uv is just x ln x squared minus, inside we have du dx, which is 2 ln over x, times v, which is x. So just this times v will cancel out, so the x and 1 over x will cancel out, so we'll only have 2 ln x dx. Now here the problem is that we can't again integrate this directly, but what we can do is that we can use another integration by parts inside this, because similar to what we had, again we take u equal to ln x, and then dv dx equal to 2, so we find v. And this is a very common technique that at times you will need to use integration by parts twice or even sometimes more. But normally the types of questions you'll get often need you to use once or maybe sometimes twice. So du dx is equal to 1 over x, and then when we integrate 2, we'll simply get 2x. So now here you just need to be careful that you have this from the previous part, so x times ln x squared, this term is there, and then also this negative. Now inside this we substitute the new functions for the second integration by parts. So for the second integration by parts, we have u times v, which is ln x times 2x, and that is 2x ln x basically. And then minus, inside the integral we have 1 over x times 2x, which is just 2. right? So 2dx. And yeah, so now that we have this simple integration, then we can just solve that. So we have x ln x squared minus, so minus 2x ln x, and then 2 integrates to 2x, so we have minus 2, so it is minus 2x, but another minus, that makes that positive 2x plus c. So at the end, we'll have x ln x squared minus 2x ln x plus 2x plus c. Just one thing to note is that here there's actually abuse of notation, because I already used u and v in the first integration by parts, and then in the second one I also use that again. But I mean, if you want to be really rigorous, then you'd better use other letters in this case instead of u and v. But since I just more like a convention that we use u and v for integration by parts, it's not a very big issue.